Welcome to Geometry International Honors. This is Mrs. Patterson, and this is the first of a series of videos to help you with your summer assignment. So with no further ado, let's get started. Your summer assignment begins by asking you to write the equations of lines, and some of the problems look like this one. Now, this isn't a problem from your summer assignment, it's an example. You have some problems that look like this. Write the equation of a line that passes through a couple of points. All right, and you're asked to write the equation of that line in two different forms. One of those is what we call point-slope form, and point-slope form looks like this. Y minus the y value of a point is equal to the slope, which we use m to represent slope, times x minus the x value of a point. So let's start by finding m, the slope. And you'll recall that slope is a ratio, and it's a ratio of the difference in y values to the difference in x values. So to find our slope, we'll take the coordinates of our 2 points. Let's call this one x1, y1, and let's call this one x sub 2, y sub 2. So we'll subtract those y values on top. That would give us negative 0.5 minus 1.9 in the numerator, and then the denominator is the difference of your x values. So that second x value is negative 4.8, and then we're going to subtract 2.4, the first y value. All right, so a little bit of arithmetic. If you take negative 0.5 minus 1.9, you'll get negative 2.4, and negative 4.8 minus 2.4 gives us negative 7.2. Now we can reduce that ratio. Well, we can reduce that ratio, and negative divided by negative is a positive, so we'll end up, and 2.4 goes into 7.23 times, so we end up with positive 1/3. All right, so now what we can do is, we now know what our slope is, and we will replace m with that slope. That slope is positive 1/3. Oops, I don't know why that turned yellow. All right, so let's do that, and then we're also going to replace in our equation, we need an x1 and we need a y1. So at this point, you have a choice. You could use either of these points. I'm going to go ahead and use the first point this first time, and I'll let 2.4 be my y x sub 1 and 1.9 be my y sub 1. Let's plug it into the formula, and we will have y minus, remember y sub 1 is 1.9, is equal to our slope, which was 1/3, times x minus the x value of our point, which is 2.4. Now, at that point, you're done. That is an equation of a line in point-slope form. I want to point out, though, that you could also have written it in another form. If you decided to choose the other point, if you had used this point for your x1, y1, then that equation, which is actually the same equation, it's the same line, it's just a different form of that equation, it would be y minus, instead of 1.9, it would be y minus negative 0.5, which is the same thing as adding a 0.5, is equal to that same slope of 1/3 times x minus a negative 4.8, which is the same thing as plus 4.8. All right, so either of these equations would be the answer to part 1 that asks you to write the equation in point-slope form. But we're not quite done. Now what we need to do is take either of these equations. It doesn't matter which one we choose, but we're going to take that and write it in what's called point-slope form. So I need a little more room, so I'm going to erase our slope work here, and we'll use this space to write the equation in slope-intercept form. All right, so slope-intercept form looks like this. It looks like, oops, let me change color. It looks like y equals mx plus b, and you'll recall that m is the slope of your line and b is what we call the y-intercept, so that's why this is called slope-intercept form. So what you can do is take either one of these equations. It doesn't matter which one. I'm going to go ahead and just choose the first one. Y minus 1.9 is equal to 1/3 times x minus 2.4, and all we have to do is take that equation and solve it for y. Once we have solved it for y, it'll be in this form, in this y equals mx plus b form. So to solve for y, let's start by distributing on the right side and getting rid of those parentheses. So we'd have y minus 1.9 equals 1/3 x minus, when you take a positive 1/3 times a negative 2.4, that would be negative, and 1/3 of 2.4 is 0.8. Okay, and then just one more step to get this solved for y. Let's go ahead and add 1.9 to both sides to isolate that y. And we'd end up with y is equal to 1/3 x, and then negative 0.8 plus 1.9 gives us a positive 1.1. Now, if you had taken the second equation, if you had taken this equation and solved it for y, you would have gotten the same thing. So that's the second part of your problem, is writing the equation in slope-intercept form. This is another example of the kind of problem you'll see on your summer assignment. In this problem, you're given the graph of a line and asked to write its equation. So what we're going to do is find what we call two pretty points. Those are points whose coordinates are integers, and they're really easy to read. Then use those 2 points to write the equation of the line, again in two different forms. The first one being point-slope form, which looks like this: y minus y sub 1 equals the slope times x minus x sub 1. So I need the slope m, and then we also need an x1 and a y1. So let's look at our graph and find a couple of points so we can do that. So it looks like this is a pretty point. Its coordinates are, let's see, its coordinates are 0, -3. And then another pretty point looks like this point right here, whose coordinates are +4, -2. All right, so let's first of all find the slope. Let's take that difference in y coordinates to difference in x coordinates. All right, so that would be, let's see, -2 minus a -3 would be +3 on top, and then the denominator would be the difference in x coordinates. That would be 4 minus 0. So that simplifies to, let's see, +1/4. So we have our slope of 1/4. Now let's pick either one of those points. It doesn't matter which one. I'm gonna pick this point, the 0, -3 for my x1, y1, and write the equation in point-slope form, and it would look like this. Y minus a -3, that's the same thing as y plus 3, is equal to our slope of +1/4 times x minus 0. Now, another way I could have written that, I just could have written y plus 3 equals 1/4 x. So that is one way to write the equation in point-slope form. Or if we chose the other point, if we wanted to use this point and call it x sub 1, y sub 1, the equation would look like this. Y minus the y value of that point, that would be subtracting in -2, which is the same thing as adding 2, is equal to that same slope of 1/4 times x minus the x value of that point. So that's a second way to write the same equation, the equation of the same line, in point-slope form. But then you were also asked to write it in slope-intercept form. So we can take either one of those equations. How about we just take the second one? We're going to take this one, and let's solve it for y and get it in slope-intercept form. So if I'm going to solve this equation for y, I'm going to start by distributing on the right side, and I'd have y plus 2 is equal to 1/4 x minus 1/4 of 4 is 1, and then I'm just going to subtract 2 from both sides and get y is equal to 1/4 x minus 3. Now, this equation in slope-intercept form, we would get this equation if we had taken our first equation in point-slope form. If we solve that for y, we would get the same thing. Y equals 1/4 x minus 3. You'll also see some problems like this on your summer assignment. It says, write the equation of the line that passes through these 2 points, and what I want you to notice is that the y values of these 2 points are the same. So let's graph those points so you can see what this line would look like. So we'd have 1 point at, let's see, at -1, 4. So from the origin, we go to the left 1 and up 4. So let's put a point there. And then we also have a point at 2, 4. So from the origin, we'll go to the right 2 and up 4. And you'll notice that these 2 points, oops, I put it in the wrong spot. It should go right here, sorry. You'll notice that these 2 points line up horizontally. So this is a horizontal line. It's a line where the y values are always the same. Notice that it crosses the y-axis, okay? So when you have 2 points whose y values are the same, the equation of that line is always going to be y. If it's a horizontal line like this, it's going to be, the equation will be y equals some constant, okay? And in this case, that constant is +4, so y equals 4. And finally, let's write the equation of the line that passes through these 2 points. Now notice that these 2 points have the same x value. So let's graph those points. We've got 1 point at 3, -2. So from the origin, we go to the right 3 and down 2. So we have a point at 3, -2. And then the other point is at 3, 5. So from the origin, we'll go to the right 3 and up 5. All right, so that point is right here, and you'll notice that this time these points line up vertically. So when we have a vertical line, a vertical line where every point on the line has the same x value, notice the line also crosses the x-axis. We know that that line is going to look like this, or the equation of that line is going to look like this. X equals a constant. Okay, and in this case, that constant is going to be +3. So the equation of a vertical line will always be x equals something. In this case, it's going to be x equals 3. Okay, so I hope these examples have been helpful for you. I will make some more videos and post them for the other parts of the summer assignment. And then, of course, when school starts, you can always ask me for help either during class or before or after school. So I hope this helps, and I will be seeing you soon.